The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Problem number 2, we're asked which of the following graphs is symmetric with respect to the origin. So remember that origin symmetry is the other way of saying if something is an odd function. And remember that for an odd function, what that means is if you plug in f of negative x, you have to get negative f of x. So if you plug in an opposite value for x, you have to get the opposite value for y. So that's what we're going to be looking for here. So y equals square root of x. Let's go through these one by one. Well, if you plug in a positive or a negative value for x, you're going to get one of them to be undefined. Because if x is negative, then it's just undefined already. If x is positive, then when you take the negative of it, that's going to be undefined also. So we definitely do not have that one being symmetric with respect to the origin. So B, we have x, y equals 1. Let's rewrite that as y equals to make this a little bit simpler. Okay, so what this is saying is if this is an odd function, if we were to plug in a value for x and its opposite, we should get opposite but equal values for y. So we can try that with a variety of different things here, but it's good to show it algebraically and not just use numbers. So y equals 1 over x. What happens if we substitute negative x in for x? We would get negative 1 over negative x, or in other words, negative 1 over x. Is this the opposite of that? Yes, because this is negative y. So this is the one that is opposite when we plug in x and negative x. It is symmetric with respect to the origin. Some little tricks that you can use to help you there. For example, in letter C, we have y equals x to the 4th. Whenever you have a polynomial that has an even degree, it definitely cannot be odd or symmetric with respect to the origin. So we know that one's wrong for sure. And similarly, if you were to add two even functions, you would also get an even function. And that's what D shows here. We have y equals x squared plus absolute value of x. Absolute value of x is an even function because if you plug in the negative value, you get the exact same thing. X squared is an even function because if you do your negative value, you get the exact same thing. Remember in this one here, when we plugged in our negative value, we got a negative, which is odd. So if you plug in a negative and you get the exact same thing, that's even. So we have an even function plus another even function. That's guaranteed to be an even function. So this is definitely wrong as well. And we get that B is the only one that is odd. Again, that means symmetric with respect to the origin.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.